What if pgVector searches were 100x faster without upgrading hardware? Every team building RAG applications eventually hits this wall. Vector searches take 5 to 10 seconds, queries timeout under load, and you cannot scale to real-time interactive use cases. Most teams think the solution is bigger databases or more powerful hardware. But the real problem is they're using default index settings. As a top 18 PostgreSQL expert worldwide, I've helped companies optimize vector performance without changing their infrastructure. Here's what most teams do. They create HNSW indexes with default settings f_construction at 40, ef_search at 10, and m at 16. These defaults work for small data sets but completely fail at scale. I've seen companies trying to add more CPU, more RAM, more everything, when the issue was just index configuration. They're throwing money at hardware, when tuning parameters would solve everything. Your vector searches shouldn't take seconds, they should take milliseconds. Index tuning matters more than hardware for vector search performance. When you stop thinking about bigger hardware and start thinking about optimized parameters, pgVector transforms from slow database to real-time engine. HNSW indexes have 3 critical parameters that control speed versus accuracy trade-offs. Tune these for your workload and you'll see 50 to 100x performance improvements. Here's what you need to do right now. Step 1. Understand the 3 parameters. f_construction controls index quality during build. Lower values like 40 mean faster build time but less accuracy. Higher values like 200 mean slower build time but more accurate results. Sweet spot is usually 100 to 150 for most workloads. ef_search controls how many neighbors are searched during a query. Lower values like 10 give faster queries but less accuracy. Higher values like 100 yield slower queries but more accurate results. Sweet spot is 40 to 60 for interactive queries. M controls maximum connections per node in the graph. Lower values like 16 use less memory but slow searches. Higher values like 64 use more memory but speed up searches. Sweet spot is 32 to 48 for balanced performance. Step 2. Create an optimized index. Drop the default index and create an HNSW index with M set to 32 and ef_construction set to 128. Step 3. Configure runtime parameters by setting hnsw.ef_search to 50 for the session or globally. Step 4. Test and measure query times before and after optimization. Step 5. Create multiple indexes for different patterns, fast approximate for interactive queries and accurate for batch operations. 6 months from now, your RAG application will deliver real-time responses without timeouts. Your users will get instant similarity search results, and your vector database will scale to millions of vectors without degradation. You will save thousands on hardware upgrades because tuning indexes gives you the performance you need. Your team will stop debugging slow queries and focus on building features. Yes, it takes a few hours to understand these parameters, test configurations, and measure results. But that is nothing compared to months of slow searches and frustrated users. If this resonated with you and you are struggling with slow vector searches, connect with me on LinkedIn. I would love to help you optimize your pgVector indexes for your specific workload.